In the last lesson, we discussed the case of traffic light control based on FB for S7-1200. In this lesson, we will demonstrate the specific programming operations for this case. Now, we will explain the traffic light control program based on function block FB. Create a new project named Traffic Light Control at an Intersection. And select CPU 1214C DC. First, create a variable table named Traffic Light at an Intersection and define I/O signals in the variable table. This case has two input signals. Start button, address as I0.0. Stop button, address as I0.1. There are 6 output signals. 3 red lights and 3 green lights for the east-west direction and the north-south direction. East-west red light, Q0.0. East-west green light, Q0.1. East-west yellow light, Q0.2. North-south red light, Q0.3. North-south green light, Q0.4. North-south yellow light, Q0.5. In the program block group, add a new block by selecting function block FB, rename it to Traffic Light Control at an Intersection. Choose LAD language, and click Confirm. This adds a new function block FB in the program block group. Next, we declare local variables for the function block FB. Double-click FB1 and enter Start and Stop in the input interface. Since the green light needs to blink, we declare a blinking clock here. In the output interface, enter the east-west red, east-west green, east-west yellow, north-south red, north-south green, and north-south yellow lights. Next, we write the subroutine. Since the control logic of this case has been explained in the last class, we will not explain it in detail here and directly input the program. In Program Segment 1, add a Start button and set the Start status variable M10.0. In Program Segment 2, write the Stop Control program. Add a Stop button M10.0, coil M10.1, and self-locking M10.1. Continue to enter the ladder diagram. Here we add a timer, which by default pops up the background data block option. Click Confirm. Select the output point of the timer as the self-reset control. The control cycle of this traffic light is 60 seconds, so we input 60 seconds here. Select the comparison instruction and control the output of red and green lights according to the requirements. When the current time of the timer is greater than 0 seconds and less than or equal to 30 seconds, the east-west red light is on. When the timing time is greater than 0 seconds and less than or equal to 25 seconds, the north-south green light is on. When the timing time is greater than 25 seconds and less than or equal to 28 seconds, the green light blinks. And here we set a variable for the blinking clock. When the timing time is greater than 28 seconds and less than or equal to 30 seconds, the north-south yellow light is on. Now let's write the north-south direction. When the timing time is greater than 30 seconds and less than or equal to 60 seconds, the north-south red light is on. When the timing time is greater than 30 seconds and less than or equal to 55 seconds, the east-west green light is on. When the timing time is greater than 55 seconds and less than or equal to 58 seconds, the north-south green light should also be on. And we add a blinking clock for it at this time. When the timing time is greater than 58 seconds and less than or equal to 60 seconds, the east-west yellow light is on. We compile and find there is an error. Double-click on the error message, and the system directly jumps to where the error occurred. A variable was not defined here, the timer. Let's compile again. There are no errors. Double-click on the main program. Drag the function block FB into program segment 1. Click Confirm. Now the encapsulated function block FB has been dragged in. Configure actual parameters for each formal parameter. Start button. Stop button. And blinking clock. Use the system's built-in clock pulse. Click on PLC, Properties. Find the System and Clock Memory in the General tab. Check these two boxes, click Confirm. Choose a 1Hz pulse M0.5. Here it is set to a 1Hz pulse by default. For the east-west red light, select east-west red Q0.0, east-west green Q0.1, east-west yellow light, north-south red light, north-south green light, and north-south yellow light. In this way, we have completed the call of the function blockFB and assigned actual parameters to each formal parameter. Click the Compile button, and the compilation is complete without any errors. Then we can download the program to the simulator for simulation. Please complete the subsequent steps independently. That concludes today's lesson. Please practice more after class. See you next time.